port address. Port address.
All right, it's the network address, and this piece of information represents the port that's associated with the address. So this is the port. To the right of the colon is the port it's using, and to the left of the colon is the IP address. So this is the IP address of the server. And this is the port that it's using. What's the port that's being used here? What's the number of the port that's used in this socket?
518. No, after the double colon.
Yes,
Colon.
yes. After the colon, 51874 is correct. And do you know the IP address of the client? What is the IP address of the client?
174.5. No, sorry. Yeah, 48. That was that right there. 86, 174, 52, 48.
That's correct. That is correct. That is the IP address. Now, once again, is the client listening or requesting? Is the client listening or requesting?
Requesting.
Requesting. Yes, the client is requesting. Client is always requesting a resource. Okay, we got to get that like reflex, right? Like you can snap your fingers, reflex, client, right? You have to know the well-known server ports for designated services like email, like web mail. When we say POP email, we're talking about web-based email, webmail. This is secure email, or there's another kind of email that is secured in Google. Gmail uses 993. This is used on Active Directory domains to coordinate how computers work together in an enterprise or company. File transport protocol. This is to transport file services. When you create a network share, when you map a network drive and you decide that you're going to connect to a network resource on a server for a directory that's shared, that uses port 445. It's called SMB. So file shares use port 443 on the server, right? Kerberos is for authentication when you're logging in. If the firewall blocks access to Kerberos while you're in a corporate or government environment on a network, then you cannot operate with logins, okay? We said SQL is database, right? So 1433 and 1434 are very important ports, but hackers love those ports because they know that there's a database, large, organized, sensitive information. Look at this one, airline messaging, 350 to 351. We call those scary ports because hackers know which ports on the network they can do their nefarious and clandestine and dastardly business, right? Tor, the onion ring, this is called the dark web, uses 8.1 and 8.2. All right, we go into that quite a bit more when you're dealing with things that have to do with cybersecurity. In some of our cyber courses, we go into the onion ring. Here's 401. If you have an IP address and it's using port 401, it could be a battery backup. Wouldn't it suck if you could identify the port number as 401 and then realize, oh, I'm going to connect to this with its IP address. Now that I know the port, what the port is used for, what's the IP address associated with it? I just look. If I see 401 here instead of 51874, I know, this is a UPS. I wonder if I can log in and shut it down. I wonder what's connected to it. I don't know, security cameras, email systems. That's why we say they're scary ports, okay? Iscsi. This is what storage area networks are used. A storage area network is a very large disk array that's provides hard disks across a network-based disks. And put another way, it's the storage that's used in data centers. So if you find an IP address with, hold on. If you find something that has to do with 860 in the socket, then you know that it has to do with data center storage. So that's what hackers do. They basically understand how sockets work and how to create an application. Now, what I'd like to do is get into this piece right here. And what I'd like to do is now you have these slides and they're on Blackboard. But the thing that I want you to understand is that sockets are formed before a session is created. And when a session does not have a connection, it typically uses UDP for the transport layer 4 protocol. They're sending messages, right? So when we say messages, we mean short chunks of data that can be repeated if they don't get through. A stream connection is a continuous connection. The session has to be connected for the stream to flow completely. So the stream model or connection model is TCP. We said that most programmers create network applications using TCP because they want to make sure things get there. Here's the other side, okay? So this is most important. You saw the server side here. This is what I showed you before. Here's the client side. Much simpler, isn't it? You create a socket. You connect to a host that is it's listening. You know that this is a server. And how do you know it's a server? Well, we're going to get to that in a minute. You know it's a server when you have a naming system called DNS, Domain Name Service. So you tend to know where the servers are in your network based on their names and their given applications and purposes, right? So you reach out and request to that server with a connection, and there's send, receive, send, receive. I want you to notice this is send, that's receive. This is receive, that's send. Does everybody see this?
Yes.
Okay, does everybody see connection, request, accepted? Yeah? Connection request, yep, connection requested. If it's a connection, it's requesting, that's TCP. If it's just a session where it's just passing a chunk of data, it's not forming a persistent connection. Now, TCP uses something called a three-way handshake to establish the connection. We're going to talk about that in just a moment, okay? Here's the thing I want to impress upon you the most. What's this last step for both of them? Come on.
Close.
Close. Guess what happens if you don't close a socket?
It overworks itself?
In a manner of speaking, yes. You have open network connections. If it's not closed and the other side drops, you have a socket that's in place and it's exposed. That's very bad. It uses up resources. It causes all kinds of problems. Okay, so let's let's search for the term handshake. Everybody see this?
Yes.
Yes.
So when a TCP session is formed, it creates a reliable connection. And in order to guarantee a reliable connection, there's this checksum, right? So it starts with a three-way handshake. The three-way handshake starts, okay, where it sends a SYN packet. That's a packet that says, hey, I want to synchronize. I want to synchronize. I want a connection where we can synchronize data, SYN. The other host says it receives the SYN packet and it goes, okay, I want to synchronize. I acknowledge your synchronization. Let me say that again. It responds by saying, I want to synchronize. Oh, and I acknowledge your synchronization request. Okay. The other host says, okay, I get that you want to synchronize also, and I acknowledge your interest in synchronizing back my way. And the other host says, okay, I acknowledge. Now that seems kind of complicated, but the thing I want you to understand is that somebody sends a synchronization request and then it's received. The other host responds by saying, hey, I want to synchronize too. Oh, and I acknowledge your synchronization request. And then it's received on the other system, right? And then that first system says, oh, okay, I acknowledge that you want to synchronize also. And when it says, okay, I acknowledge this, it sends that ACK back. It's called an ACK. It's a special packet. That last one says, all right, I receive your acknowledgement. Now, once both have requested synchronization and both have sent acknowledgements and received acknowledgements, you send an acknowledgement and you receive an acknowledgement. You send a SYN and you receive a SYN. Without send and receive, both SYN and acknowledgements, both ways, the connection does not happen. But it happens in 3 quick handshakes. 1, 2, 3. It happens very fast. Now, hackers know how to get in the middle of this. And what they'll often do is they'll start a synchronization request, but then they won't respond. And the other one goes, okay, I want to synchronize too. I acknowledge. And then this first host just sits and lurks and waits and leaves it open, right? They leave it open. Why? Why would they leave it open? Well, we just explained, didn't we? If you have an open connection, you're not closed off on the network. You're open for business, except you're open to who? That's a bad place to be. Does everybody understand what I'm talking about here?
Not quite.
Kinda.
Okay.
What's supposed to happen is that the other side of this equation is supposed to close off after it doesn't get a 3-way handshake. Okay, so when a TCP connection is supposed to form, if the other system doesn't respond, what's supposed to happen is that it drops and closes. That's what's supposed to happen. All right. So once again, if it's a very high number, that's usually the client, and it's usually requesting. And those are randomly chosen by the client. The client says, okay, I want to request a service or a resource. So I'm going to pick a very high port number and bind it together with my IP address, form a socket. Now I'm a client. I have a client socket. I'm going to go looking for a server. The server forms unique sessions with each and every client because one piece of information is always different. And it's usually this one here. It's usually the client port that's used that's different. This number stays the same. These numbers stay the same. The server socket rarely changes. This is a session, okay? And a session can be a connected session, TCP, or connectionless. All right, so we have two different kinds of internet applications, those with a permanent connection, three-way handshake, and those that are just passing a quick message, a quick chunk. DNS, between DNS servers, a DNS server, this is really critical. I want you to watch this several times over the weekend. This YouTube video, I'm going to fast forward a minute because there's a piece of this I want to show you.
That's how computers and other similar devices talk and identify with each other over a network, which is by using numbers such as IP addresses. Humans, on the other hand, are accustomed to using names instead of numbers, whether it's talking directly to another person or identifying a country.
Okay, you get the point. Let's fast forward. When a server is working, when you're asking for yahoo.com, on your PC, you've configured a DNS server. Usually your internet service provider has a DNS server that's running. And what happens is that you say, hey, I want to know where yahoo.com is. And that DNS server first goes out to the dot server. It's called the root server. There's actually a dot that's missing at the end of the com. That root server says, hey, I need to find Yahoo, but it's a .com. It's not a .gov. It's not a .edu. It's not a .net. It's not a .org. See, this is the first level of the domain name. The main level of the, it's called the primary, right? It's the top level domain. So a top level domain is a .com, a .edu, a .gov, and there's thousands, millions of .govs and millions of .coms. So the resolver asks the root server, which basically knows where all of the top level domains are. Hey, I need to find .com. And the dot server goes, okay, here are the .com servers. The .com servers know from this DNS server, hey, I need to find Yahoo. So the .com servers know this is where Yahoo is. So they each hold a piece of this. It's like a chain reaction.
Root server. The root servers are the top or the root of a DNS hierarchy. There are 13 sets of these root servers, and they are strategically placed around the world. So when a root server receives the query for the IP address for yahoo.com, the root server is not going to know what the IP address is. But the root server does know where to send the resolver to help it find the IP address.
It knows where to send the
So
request.
the root server will direct the resolver to the TLD or top level domain server for the .com domain. So the resolver will now ask the TLD server for the IP address.
I want you to notice this DNS server first goes to the dot server, says, hey, where are the .coms? Then it goes to the .coms. Then it gets an answer back about Yahoo, and then it goes to the server that has Yahoo. The one that knows Yahoo is called the primary domain name server, the primary. Everybody remember Transformers? Optimus Prime, right? The lead, primary. Okay, so there's one copy of the yahoo.com zone. Those are the records of domain names. So when you go to the yahoo.com webpage, if you use yahoo.com email, there are records in there that tell you, okay, here's the web server, here's the email server, here's where you go for, customer service, whatever. All of those are on the primary. Now, sometimes the primaries need help. It's often a good idea considering how critical this whole process is. We use it all the time. We don't even think about it, that there are extra copies of it that are read-only copies. Those are called secondaries. They're not primaries, they're secondaries. They're read-only copies of the zone, the set of records that tell you. Okay, you need to watch this a number of times. You need to memorize this video. Memorize it. And here's the part that I want you to understand though. DNS is a critical service for clients on a network that use named resources. Named resources. Named resources. Oh, come on. No, I can't even type something here. No. Okay, I'm on campus and for some reason I can't log in. When you have named resources that are accessed across a network, you have to have some manner of resolving the names. And DNS is the standard for how to work that process. The thing that I want you to understand is that the transfers of records on this level between servers, that's managed with TCP IP. So between servers, when something is a primary, it's said to be authoritative for that domain. So there is a single yahoo.com domain server. And Yahoo treats that server very seriously. Because if that server dies, the only thing they have left are read-only copies. So they try to do all they can to protect that authoritative server that has the yahoo.com zone. The collection of DNS records together is called a zone, a domain zone. All right, so the DNS servers, when they talk, and they're doing this thing where they're back and forth with each other, right? When they're talking between DNS servers, that's handled with TCP because the records need to be exchanged with accuracy. But when this resolver finally answers that PC or that laptop or that iPhone or that Android smartphone or tablet, the client that requested it, that's done with UDP. It's very important that you understand that DNS has kind of like a dual, it has like a dual characteristic. It uses TCP connections between DNS servers, but when clients are asking, hey, where do I find facebook.com? That's sent by UDP and not by TCP, okay? Once again, on page 4 of our study guide, you need to click on this and watch it, watch it, watch it. Memorize slide 503. That's the handshake. We just covered that. Any questions? All right, let's keep moving. It's important for you to understand that how firewalls work. So I want to take a look at a firewall real quick. A firewall will take inbound network requests and it will block them based on an IP address or a port or both. What are we saying? Firewalls are network security appliances that block unwanted or unauthorized inbound network data. Now, here's the problem. If you click on a link in your email message or you're on a website and you're seeing something cool and you click on a link, if that takes you somewhere malicious, it's gonna saw right through that firewall. So you're making the request, you're saying, hey, I wanna see this right here. So you click and that request goes out of your firewall because the firewall blocks inbound incoming network data requests, not outbound, okay? It only blocks inbound. And this is a big problem because a lot of people don't get that, okay? Now, suppose, let's get back to our server. Let's say we want to add an internet information service to a Windows 10 machine so that it'll run a web server on your Windows 10 machine, right? What you're going to have to do is open a port on the firewall so that when people want to connect to your system, they can get to that web page through port 80 or port 443. So then your laptop is running a web server and it's listening on your address on this port. In other words, it's in the right neighborhood. It's in the same network. It knows the address of the building and here's the floor level and door number. Okay, so if this were a multi-story skyscraper office building kind of thing, I'm going to room 80. If I want a web server at this building, I have to go to door number 80 in order to get into that web server in this building. That's literally kind of what's happening here, or that's one way to look at it, okay? Now, if you don't have that firewall set correctly, none of your stuff will work. And this is one of those things that really frustrates people, but you can easily create a simple rule. Okay, so here's an example of a command you can use. It's called the netsh command. And there's an advanced firewall option that allows you to add a firewall rule. And if you had a database server on your laptop and you were developing database solutions, you could say, okay, I want to call this rule name Open SQL Server Port 1433. That's the name of my rule. And the direction is going to be inbound and it's going to be on port 443, right? And I'm going to allow TCP on 1433, right? So you can click on this link and it'll show you how that works. You have to know how this stuff works in order to be able to create software. And the stuff we've been talking about are basic concepts from what's known as the socket API, the application programming interface. There's a cool socket interface in Python, in Java, right? And so basically, when you're creating these sockets, you got to remember, though, as a programmer, you have to close the socket. And you also, like any other good program, you return 0, right? Basically close out your program gracefully. So you want to reduce exposures. You want to send an end of file. You want to help signal, hey, I'm done. I sent here's the end of file. I don't need this anymore. And the connection usually closes. If you don't close the connection, send EOF or end of file. It's like creating an application where you don't take out the trash and return 0 at the end of it. I'm talking about stuff from your introductory programming courses here, right? Does this ring a bell, I hope, for some of you?
Yes.
Okay. Now, the one thing that you want to know about peer-to-peer networking is that both hosts act like the client and the server. And they leave a lot of junk open. So all of that BitTorrent, Tor stuff, dark web stuff, a lot of people get infected because of what? Oh, it ad hoc means, yeah, we're just going to do it. We don't have any rules. We're just going to connect. We're just going to leave the connection in place. Yeah. Because if you're doing BitTorrent and everything on your system, you agree to serve up to everybody else too. See, you're not just a client getting stuff with BitTorrent. You're also a server, which means that your system is serving up data files and resources.
And in some cases, unfortunately, there's stuff that goes out of your system you're not even aware of. Just thought I would share that little tidbit with you for those of you that are fans of BitTorrent, free music and movies, all that free stuff. It ain't free. Somebody's in your Kool-Aid, and that's what's going on sometimes. Anyway, all right. So here are some examples
of some code methods that are used to create the server socket in Java. So you can click on this link and check it out. Now, basically, I may ask you questions on the assessment. Hey, what is this a method for? And I might ask you, is it a Python method for a client socket? And you're going to go, no, I see the word server here. I also see the word Java. So this is what is creating a socket on the server with a Java application. Everybody get what I'm talking about here? It's pretty obvious. It's pretty plain stuff. It's not really rocket science here. Okay, so I need somebody to give me a domain name you'd like to create. Just make one up right now. Okay? Can somebody do that for me right now? Seriously? I don't have any takers. Nobody can think of a domain name they'd like to create for a notional interest or business of yours?
Totally anything, like
Totally anything. I mean, not something that's already taken, right? Let's create something that's different.
I'm thinking. How about Caltech? Caltech?
How do you spell that?
do KAL
Uh-huh.
TEK.
Okay. You know, there's a university named California Institute of Technology, and their nickname is Caltech, right?
Oh no, I didn't. I just tried to use my name and then put tech in it.
Can everybody see this? So let's do this. I have a server that's a DNS server, and it's called Vega. And I want to create a new domain. So I'm going to create a new zone, and I'm going to call it just what you said. It's a primary. So this is the first one of its kind in the world. You said KAL. Tell me again. TEK, Caltech. What would you like? .biz, .net, .org, .com, .gov. Oh, by the way, you can't use .gov unless you are, I don't know, a government organization. You can't use a .edu unless you're, I don't know, a school or a university. But you can use .net, .com, .biz, .org. What would you like?
.net.
.net, Caltech.net. Does everybody see what I'm doing here? Now I've just decided that in this domain, I want to create a host name. And I'm going to create an alias, okay? An alias is like, it's called a C name. It's a custom name, right? So I'm going to use a new host name, and I'm going to call this Jupiter, because I have a web server named Jupiter. Okay? So we're going to pretend that your domain, caltech.net, needs a home. That makes sense, right? Wouldn't it be nice to have a home? And what we have here is a web server. And when you look at it, in just a minute, it'll say, hey, I'm a web server. Everybody with me so far? We're almost done, by the way. So I have Jupiter. And Jupiter is sitting on a specific IP address. And what I want is for the world to find this website that I'm going to use as a landing page for my caltech.net domain. Are you ready? So I'm going to go back here to Vega, and I'm going to put jupiter.caltech.net. The name of that host is called Jupiter. And so I'm going to put in that address. And I'm even going to create like a reverse lookup record. So if somebody uses the IP address, they'll know we're talking about caltech.net and we're talking about Jupiter. Now I just created that successfully. The problem is that I don't want people to know the name of the server. That's bad. I'd rather have the web page pull from using something like, I don't know, www. So what I'm going to do is I'm going to create an alias. And I'm going to call this www. And I'm going to browse back to Vega in the forward lookup zones into caltech.net to the record that says Jupiter. And then here's one more thing I'm going to do. I've just created this domain name, this pair of domain name records. And then there's a third one in here that's a reverse lookup for Jupiter. Now I'm going to go ahead and I'm going to clear the cache on this DNS server. And then I'm going to go ahead and restart the service. And now I'm going to go ahead on another machine and I'm going to ask for www.caltech.net. Is everybody with me? We're almost done.
I'm with you.
Caltech.net. I'm going to log into Orion. Orion's a different server on the same network. And, you know, I've heard there's this really cool new domain out there on the web. And so I'm just going to open up, like, I'm going to open up a web browser. Oh, and I'm going to go ahead and do this too. I'm going to clear my DNS cache just in case somebody tried to search for that before and it didn't exist yet. So I'm going to flush my DNS cache. Okay. Now I'm going to go to www.caltech.net. Are we ready?
Yes.
Oh, I got a web page. Now, we didn't set up your web page, did we? But we could. All we'd have to do is go on to Jupiter now and go to town, set up a web page. Now I'd be ready. What do I want you to do over the weekend? I want each of you to come up with your own unique domain name. If you were to start something, a whole new company, start a revolution, become the next Google, the next Instagram, the next Snapchat, the next WhatsApp. You get the point. The next Yahoo, the next Microsoft, the next Amazon. Where would you start out on the internet? What name would you use? That's what I want you to think of. I'm going to post an assignment where I ask you to choose a domain name and email it to me. It needs to be a domain name that's unique, that's custom for you, something that's special, something that nobody else has used before. Okay?
So I can't choose mine.
Oh yeah, you can. You can use the one we just demonstrated.
Okay, thank you.
In fact, you can just email it and you're done, because you were the person who volunteered in class. Are there any questions about DNS and how it works, the domain name service? Okay, stay tuned for the assignment. Thank you for joining us. I'm going to stop sharing and stop recording. And